Good afternoon. This is Rich Nass, Executive Vice President with Open Systems Media, and I'm here for this week's installment of 5 Minutes With. So this week, I'll be speaking to Michael Heflin. He is the CEO of Sensuron. Good afternoon, Michael. How are you?
I'm doing great. It's good to have this conversation.
Thank you. I agree. I definitely agree. Okay, so we normally don't like for people to talk about their own companies when we do these 5-minute interviews, but the story of how your company was formed was actually very interesting. So if you could just give us the real short version of that story, I think the audience would really appreciate that.
It is an interesting story. It actually starts in 2003. NASA had developed an aircraft. It was the Helios unmanned aircraft, and it was designed to fly at the highest heights, 100,000 feet, and stay aloft for approximately 24 hours or more. It's really a beautiful craft if you've ever seen a picture of it. But it came apart over the Pacific Ocean, and that began a series of questions, obviously. How do you invest hundreds of millions of dollars, develop something that disintegrates in flight? And the core message, I believe, that NASA came up with was they simply had been innovated beyond their ability to test. That set off a group inside NASA to have a new mission. And that mission was specifically, how do we come up with technologies and processes that keep this from happening again in the future? What is it that we need from a technology standpoint, a process standpoint, an integration standpoint, a data, information standpoint? How do we bring all of those things together to create an environment in which we can foresee these things as we continue on with innovation? Well, they began that process. They looked at standard technologies that were around at the time. That was strain gauges, thermocouplers, accelerometers, a variety of older technologies. And they began working through a series of evaluations to determine how can we make this ultimate mission of being able to ensure that our innovations are sound. And as they did, they began moving from technology to technology, and quite frankly, generations of that technology to new generations of that technology. They eventually settled on the concept of fiber optic sensing. And the reason that they did was since they were focused primarily on aerospace, but then applications ultimately to be used in other markets, as NASA always seems to do. They began looking originally at some early versions and still pervasively used generations of technology. They moved through that first generation because it didn't give them really the picture that they wanted, the amount of data that they wanted as they looked at a wing of an aircraft or the composite materials of a rocket or the fuel in a rocket tank. So many different applications that they had. Then they moved through a second generation, which was a variety of scattering technologies. Again, they ran into some fundamental issues, and then through that, eventually, they ended up with a platform called OFDR. Now, it's not as important what the platform name is. What was important was they eventually settled on a platform and discovered that they could do something far beyond what they thought. Since the original motivation was to be able to have testing tools and processes, and then that began to evolve with time, ultimately, they determined that they could have a platform, and the platform would give them a variety of types of both testing and process and data tools, all in the same piece of equipment. While they were doing that, they were working with a company, which is our partner company that we spun out of. That company's 4DSP. And 4DSP was supplying them with the cards that went into the system, the FPGAs and the firmware necessary for them to go through each one of those generations. As they did that, they ran into another issue. And that issue eventually was, since they didn't want tens of sensors, but they wanted thousands of sensors, and they wanted thousands of sensors doing different things, and they wanted thousands of sensors doing different things at high speeds, and they wanted to be able to read it and understand it all at the same time. You can imagine the amount of data that they were pulling from these fibers. About in 2007, there was an epiphany with the team. The team came up with an algorithm that allowed them to process 10,000, 20,000 sensors, doing a variety of types of sensing, all at the same time, and they began the patent process for that. And during that time period, they approached Ford ESP at that time, which is now Sensuron. They approached them and asked them if they would be interested in licensing the technology to commercialize it. And so I'll stop here with the story, except to say what they have done and they continue to do is go far beyond their original mission.
So it was actually a pretty unfortunate event that led to the founding of the company.
Yes and no. It's an unfortunate event that a lot of money was used to build something that ultimately failed. But like with all failures, there's opportunity for improvement. And this brought the opportunity of improving not only their innovation, but innovation across many different industries. And so the silver lining is probably much bigger. In fact, I would say the silver lining is much larger than the original failure.
Okay, I'll certainly buy that. Okay, so unbelievably, we're almost out of time, but I want to get into this fiber optic sensing just a little bit because it's a fairly intimidating term, but from what I know about it, it's actually a pretty simple technology. Would you just explain very quickly what it is and what some of the potential applications are?
Yes. Fiber optic sensing, as most people think of fiber optics, uses some of the same principle. The light is shined into the fiber on one end, like in the telecommunication, and it is read at the other end. What's different about this use of fiber is that the character of the fiber is actually changed. And the fiber actually has what you can think of as small reflectors running continuously all the way down the fiber. There are lots of generations out there, but the one that we use makes the entire fiber into a sensor after a sensor after a sensor. As the light hits those reflectors, most of the light passes through and a small amount of the light comes back. Well, what the technology is able to do is able to actually read what's happening at each one of those sensing points. And as it does that, it's able to interpret two fundamentals. One is strain and the other is temperature. But from those two things, a multiplicity of other things can be determined. For example, as we go into the idea of where all could this be applied. In aviation, this can be applied for load or structural health monitoring. It can be used to monitor liquid level of fuel that's in tanks, which is especially important when you think of rockets trying to reduce the fuel and increase the payload and do that difference. Or the composite fibers, as people continue to use composite fibers for the structures of aircrafts and rockets. There are obviously a lot of challenges with those composite fiber technologies. What we're able to do is help actually embed fiber into those and determine what's happening. But there's other industries, for example, applications such as 3D shape sensing used in medical and in civil type work. And that could be anywhere from a catheter going into a heart to help with the ablation process inside a heart, or it could be something similar to a project that we worked on where it's about how do you align an implant to go properly into the body to make the surgery as successful as possible. But in automotive, determining what's happening with handles and frames and temperatures on catalytic converters are application areas. And the list goes on and on of industries and applications. It's probably one of the farthest reaching single technologies that has multiple types of sensing that we know of. Certainly we've not come across anything competitive in the world that can combine all of these types of sensing into a single platform. And I'm not certainly talking about just our company. I'm talking about the technology as a whole.
And I bet you're thinking of more applications on a daily basis.
We do, and it really comes from our customers. We're amazed at the number of things that people call us and say, can it do this? And since this level of technology is a platform that does strain and temperature and liquid level and 2D deflection and 3D shape sensing, and even with coatings on the fiber, they can react to environmental issues such as chemicals in the air or in the liquid they're in, or to magnets. There's so many applications that what we see as the future of this industry is that it is one of the pervasive technologies used in all things commercial sold. And in fact, we already today, so could other people in the industry, deliver consumer-level appliances. The price points just aren't right.
Very good. Well, I'm afraid we've used up all of our time, but I'm sure readers are going to want to see more about this, and I'm sure that you'll be happy to speak to them if they want more information.
We would.
That was Michael Heflin. He is the CEO of Sensuron. I am Rich Nass, Executive Vice President of Open Systems Media, and that was this week's installment of 5 Minutes With. Thank you, Michael.
Thank you.